Okay, so in TensorFlow, you literally will say, for example, if I call it S1, just like we were doing before, you'll say S1 equal to W1 X plus B1. Okay, of course you'll match the matrix dimensions. Okay, then you will do something, suppose we call it A1 equal to whatever sigmoid or of S1, and then let's call it S2 equal to W2 A1 plus B2, and then A2 equal to whatever sigmoid or softmax or whatever, right? Okay, and lastly, you will define the loss function. For example, this could be y minus A2 squared, okay? So literally you're writing the architecture as a sequence of statements in programming, like we do normal programming, right? But here's the beauty of it. In TensorFlow, we do not need to compute gradients. So the code that updates the weights, that creates the partial derivatives, is done automatically for us. Okay, how? Okay, so no partial derivatives. I was talking to a student who took the class last night, and now obviously he's using TensorFlow, and said, "Professor, you spent half the semester on those partial derivatives. We don't even use them." So, of course, the answer is, if you didn't know how the backpropagation works, then your knowledge is superficial, right? So moving forward, we assume we know all the partial derivatives, all the gradient updates, and so on. So let TensorFlow do it. However, we want to create the architecture of ourselves. No partial. So the question is, how does TensorFlow do it? Okay, if I wrote a very complicated equation, suppose I say loss equal to sine of x squared plus e to the minus cosine of x plus whatever, right? How is it going to compute the derivative if I have never told it what the derivatives are? Okay, and the answer is there's a concept called automatic differentiation. So TensorFlow uses automatic differentiation. Okay, which is not the same as numerical differentiation. Automatic differentiation itself is a very complex topic. Okay, I'm working on a handout. I don't know if it'll be ready before this, so that I can at least show you. Essentially what it does the exact same thing. So if we have a computational graph, okay, so we define the loss function computationally. It will accumulate the gradients going over here, and it does it in such a beautiful way that the answer is extremely accurate, better than what we were doing before. Okay, so keep in mind it is doing all the backpropagation, all the computation of the derivatives, but not in closed form like we were doing, but in a code form, so that our results are correct. Okay, so that's why from now on, like I said, we can. Our responsibility is define the architecture. Okay, define the loss, and ask it to minimize the loss using, for example, atom optimizer or gradient descent or whatever, and it will do the job. Okay. Now, how do we set up the code? So, like I said, I have my own way of doing it, so I'll try to show you which I think should be set up properly. And once you see you'll see there's a very nice pattern to it. So in the beginning, it may look slightly confusing, but once you see the purpose of it, then any complex architecture you wanted to build, as long as you are good at coming up with your own loss function, you'll be able to easily implement it and test it on any data, right? So the other concept, as far as TensorFlow is concerned, is okay, so after we set up the architecture like I showed you, okay, so TensorFlow has concept of placeholders, variables, and constants. Okay, so for example, let's again pick the simple example. We wanted to create this type of network without writing any backpropagation code or partial derivatives. We wanted, after we defined the loss, we wanted TensorFlow to give us the trained network, right? Okay, so as you can see, the input to our architecture is basically the data X. So we'll create a placeholder, and we'll say, and we can give it some meaningful name, you know, input X or something. The exact syntax I'll show you in a second as I go to the computer. So basically this becomes a placeholder, right? Then as you write the equations, okay, TensorFlow deals with tensors, not straight numbers. So it deals with tensors. What exactly is a tensor? You know, just a multi-dimensional array or matrix. Okay, so once again, it will be your job to make sure the dimensions are matching as we, okay, so even though when I wrote it over here, I wrote it like this. In TensorFlow, if you're multiplying two tensors, you will do tf.multiply. If you're subtracting, adding, you'll do tf.subtract. Okay, so all of these will become tf.multiply, then tf.add, or subtract, or whatever. There's a built-in sigmoid, tf.sigmoid as an example, right? So that's the other concept before I show you some examples is, so you'll create some placeholders, some variables, you'll write the expressions, you'll write the loss function. So second concept is the concept of a session. So TensorFlow has concept of a session. Okay, so typically session basically means the computation session where we can give it some actual data, have it go through, right? Okay, so now let's pretend, so typically you will do session dot run, and then so you will specify an expression to evaluate. Comma, okay, data to be fed to the dictionary, two placeholders. So this is set it up as a dictionary. Okay, so for example, let's say we specified, and again, all of these were done as tf.multiply, tf.sigmoid, and so on, right? And now I wanted it to evaluate the loss or evaluate A2, okay? So if I wrote this expression, session.run, an expression to evaluate, for example, I said loss, okay? So then what we'll do is, and using the data to be fed to the placeholders. Suppose I gave it some data. So what we'll do is we'll run through whole thing one time. Okay. As it runs through, it will bring back whatever this value is. So you can just store it in val1 and display it whatever you feel like it, right? Now suppose in addition to knowing what the loss is, we also wanted to know what is the value of A2. So if you wrote another statement, session.run A2, and whatever data X that you fed to the input, what it will do is it will try to evaluate A2 now. Okay. But then it will run the whole thing again. See, we didn't want it to run it twice. We wanted it to, while it was computing the loss, we also wanted A2 to be given to us. So then, easy way to do that is ask for two things. Ask for A2, ask for loss. Because if you did it in two separate statements, like I said, it's executing the whole graph again, which you don't want to do. Okay, so those are a couple of small concepts. Let me show you the code. Okay, or let me give you a small break, and after the break, let me show you the code, and you'll see how easy it is.